Greetings and welcome to First Shots. Today I'm going to talk about something that some people find controversial and that most people, even the people who sell it, don't really know that much about it. Steel body armor. Now, I don't personally own any body armor. It's not something that I've been able to make the justification to buy. It's kind of expensive. But before I started this channel, I worked for almost 13 years in the steel industry. I'm not a metallurgist, so while my understanding is better than a layman's, bear in mind I am not an expert. Now, during my time in the industry, I cataloged and sold a lot of impact-resistant plate. And that's really what armor actually is. Impact-resistant, or more accurately, abrasion-resistant. You'll hear terms like AR500 used for armor a lot of the time. Now, ASTM is an organization that was founded to standardize the metallurgical testing process. ASTM used to mean the American Society for Testing of Materials, now it's just ASTM Inc. AR500 is an ASTM grade for abrasion-resistant steel. Abrasion-resistant steel is used in things like dump trucks and bulldozer blades and things like that. Now, there are other abrasion-resistant grades, but AR500 is the most commonly used for armor and steel targets because it closely approximates the characteristics of mil-spec steel armor plate. However, AR500 is not armor plate. Mil-spec armor plate is rolled homogenized carbon steel, usually graded as A46100 with a Brunel rating of 477 to 534. Brunel is a non-SI measure of how hard something actually is. AR500 has a Brunel rating of between 460 and 544. So AR500 can actually be harder and more abrasion resistant than armor plate, but it can also be less hard and less abrasion resistant than armor plate. Generally, the steel used for armor has a much tighter tolerance for the chemical makeup of the alloy materials than abrasion resistant steel. Armor plate often goes through additional physical processes like heating and tempering to ensure that it meets the standard. And finally, to truly be called mil-spec armor plate, a sample of the plate has to be tested by one of the few military-approved labs in order to do that. A sample is cut out of the finished plate and the lab shoots a known mass at a known velocity at the plate. The lab then measures how deep the impact dimple is, and from this calculates whether the material meets the armor specification. 1/4 inch A46100 plate is tested with the equivalent of 7.62 by 51 NATO ball ammo, that's anti-personnel, not armor piercing, at 100 meters with 30 degrees of deflection. It will react differently to match ammunition or armor piercing rounds. The distance and deflection used in this testing are very important. Most people shoot steel targets head on, but ballistically the military tests these plates at an angle. That angle works out to about a 15% increase in the relative thickness of the steel. When someone wears body armor, this deflection angle and the distance are inconsistent depending on where the threat is and how the wearer's body presents to an attacker. Body armor also only covers a portion of the body, usually just around the chest cavity. That's because no matter what material the body armor is made from, it can get very heavy. Kevlar, the lightweight fabric that protective vests and plate carriers are usually made from, requires many layers to be bullet resistant. There are other materials, but Kevlar is the original and most famous, so I'll refer to all of those materials by that name. Even these bullet resistant lightweight materials can get heavy when there are enough layers to stop a bullet. Now I have 4 scraps of steel here. Okay. One is commercial quality steel that I keep on my desk as a coaster. One is AR400, which is not as hard as AR500. One is AR500, and one is A46100 mil-spec armor plate. Now, these were cut from samples. We have a standard sample when we're testing out a machine or trying to do something with a new part. So we get these standard size samples pretty regularly. So if I put these up to the camera, Can you tell which one's which? Did I mix them up? Did I change them? No, you can't tell. You can't tell because I can't tell, and I worked with this stuff for over a decade. All steel manufactured in the United States comes with an ASTM certification from the steel mill. The supplier of your steel body armor should have requested and received a copy of the mill certification, either for a specific plate or for a range of plates the body armor was made from. You should be able to request this certification from the armor supplier. If they don't know anything about this certification, then they're probably not a reliable supplier of armor plate. If they're selling Mil-Spec armor plate, then they should have been provided with the ballistics report from that military-approved lab. No one should sell something as Mil-Spec armor unless they have that test report and can produce it. Due to this testing, armor plate is much more expensive than AR-500, even though they have very similar properties. That's why most suppliers are selling what they call AR-500 armor. Just remember, AR-500 armor is a marketing term. AR-500 is not actual armor. It's very hard, it's very close, but it's not the same thing. Now, does that mean that somebody hands me a chest protector with AR-500 armor in it and tells me we're going into battle? Am I not going to wear it? Hell no, of course I'm going to wear that thing. AR-500 is close enough that in a civilian context, the trade-off between cost and the possibility of a slightly lower Brinell hardness rating is perfectly acceptable. Given the choice, I'd take commercial-grade steel or even aluminum plate over nothing at all. In a firefight, I'd rather have something between me and the other guy's muzzle to absorb the kinetic energy and reduce penetration. Now this brings up something else: steel armor versus ceramic. The military has generally switched to providing ceramic plate armor for body armor over steel. Ceramic armor is essentially hardened clay, similar to the material that a coffee mug or a dinner plate is made from, but it's got a lot more strength. Ceramic has some benefits over steel, but also some disadvantages. Ceramic plates are generally lighter per unit of protection than steel, and they are also better at stopping certain types of bullets commonly found on modern battlefields. However, ceramic plates are usually thicker and they absorb kinetic energy by absorbing the impact rather than deflecting it as steel does. This absorption causes ceramic material to fracture and crumble, especially at the site of impact, but these fractures can spread throughout the plate, reducing its protection. So once a ceramic plate has been hit by a projectile, the military says it's got to be replaced. The police say it's got to be replaced. This isn't a problem for somebody with the resources of the U.S. military or a large police department, but it would be problematic for most civilians. Steel armor resists somewhat differently from ceramic by resisting what's called plastic deformation. When a force acts on the steel, it bends slightly and then returns to its original shape. When the force is so great that the steel is permanently bent, we call this plastic deformation. The spot where the bullet hits gets dimpled, and it's kind of like a crater. And so there is less protection in that spot, but the rest of the plate is usually still generally okay. The likelihood that a wearer of steel armor plate will be hit in the same spot twice is reasonably low. Even then, the plastic deformation might be small enough that the dimpled spot still provides almost the same protection. Continuing to wear steel armor that's been hit by a bullet is probably fine for civilian purposes and may even be fine in other contexts depending on the situation. Wearing ceramic armor plate that's been hit by a bullet or has been damaged in some other way is probably better than nothing, but it almost certainly isn't as good as wearing steel or new ceramic. Kevlar can be turned into something like a plastic plate, and these can be used as what are called soft inserts. I've seen very little real-world information on how effective those soft plates are, but more layers of Kevlar can't be a bad thing. There are some plastic and composite materials that are being used as body armor also. These are still mostly experimental, and unfortunately I don't know much about them aside from what I've read on Wikipedia. For the time being, Kevlar vests, with or without metal or ceramic body armor, is the standard. If your body armor is hit by a bullet or shrapnel, you're still going to feel it. There are numerous accounts of people's body armor resisting a projectile, but the wearer still experienced bruises, cracked ribs, and even other internal injuries. That's because even though the bullet didn't penetrate, a lot of the kinetic energy from the bullet was still transferred through the body armor and into the chest cavity. This is another advantage that ceramics seem to have over steel, at least to some extent. Ceramic armor tends to transfer less energy, while steel, being super hard like it is, tends to transfer a lot more energy. For this reason, many people choose to wear a soft rubber insert between the steel plate and their body. It might be rubber, it might be plastic, it's something to absorb some of that energy, just like a rubber butt plate on your rifle. So body armor isn't perfect, but in a high threat environment, it's extremely valuable. I hope this video has cleared up some things for you about body armor and how it works. Remember, AR-500 is not technically armor, but it's very, very close to the properties of mil-spec armor plate. Suppliers of steel plate should be able to provide you with a mil test report detailing that plate's properties. And ceramic armor absorbs kinetic energy by physical destruction of the plate, while steel absorbs kinetic energy by resisting plastic deformation. Body armor, even when worn properly, won't protect from every possible injury. If you've enjoyed this video, remember to click the like and subscribe buttons so you'll see future content. Remember, no video will ever take the place of instruction by a good firearms instructor. And remember that no video will ever replace your firearm or your body armor owner's manual. Thanks for watching. Stay safe. I'll see you at the range. During my time in the industry, I cataloged and sold a lot of impact-resistant plate, and that's really what body armor is. Let's go back. AR-500 has a brilliant steel armor resists somewhat differently, so when that force is so great that the steel is permanently blent. When a force acts on steel, it bends slightly and then returns to its original shape. I need to do that where I'm actually saying it. Okay. Kevlar can be made into something like a plastic plate, and Kevlar can be used as something, there are numerous accounts of people's body armor resisting a projectile, but the wearer still experiences bruises, cracked ribs, and even other external. There are numerous accounts of people's body armor resisting a projectile, but the wearer still. I'll get it. This is another If you've enjoyed this video, boy, I hope that didn't go off earlier than that.